The dark side of the moon is a term that has captivated the imagination of people for centuries, often shrouded in mystery and misconception. However, in the realm of astronomy and space exploration, this phrase is a bit of a misnomer and refers to the far side of the moon, which is permanently out of Earth's view. Let's delve into the scientific knowledge surrounding this enigmatic part of our natural satellite, clarify why we never see it from Earth, and debunk some common myths. The reason we never see the far side of the moon from Earth is due to a phenomenon known as synchronous rotation or tidal locking. The moon takes as long to rotate on its axis as it does to orbit the Earth, about 27.3 days. This synchronous rotation happens because the Earth's gravity has gradually slowed down the moon's rotation over billions of years. As a result, the same side of the moon always faces Earth. This phenomenon is not unique to the moon. Many other moons in our solar system are tidally locked to their planets, presenting only one face to their parent planet. The term dark side is actually a misnomer. The far side of the moon experiences the same amount of daylight as the near side. When the near side of the moon faces the sun during the full moon, the far side is in darkness, and vice versa during the new moon. One common myth is that the far side of the moon harbors alien bases or is markedly different from the near side. Scientific exploration, including satellite imaging and the Apollo missions, has shown that the far side of the moon, while having a different landscape with fewer maria, the dark basaltic plains on the moon's surface, and more craters, is as natural and moon-like as the side facing Earth. Another misconception is that the far side is a haven of darkness, which is not the case. It receives sunlight in a cycle identical to the near side, with about 2 weeks of daylight followed by 2 weeks of night. The far side of the moon has been less studied due to its position, but recent missions have begun to unravel its secrets. For example, China's Chang'e 4 mission, which landed on the far side in 2019, has been studying its geology and solar radiation environment. The far side's crater-filled landscape and the thicker crust tell a story of a different geological history compared to the near side. The far side of the moon presents unique opportunities for scientific research. It's shielded from the Earth's electromagnetic noise, making it an ideal place for radio astronomy. Future missions could set up telescopes to observe the cosmos from this quiet lunar region. In conclusion, the dark side of the moon is a term that belies the fascinating and complex nature of our moon's far side. It's not perpetually dark or mysterious in the ways of science fiction, but it holds its own unique and scientifically significant characteristics. As we continue to explore and study it, we are likely to uncover more secrets of our closest celestial neighbor, expanding our knowledge and appreciation of the moon in its entirety.